Good morning. Hello. Good morning.
Good morning, sir.
Yeah.
Good morning, sir.
Good morning. Okay. So let me check how many of you have joined. Please ask everyone to join quickly. Please ask your friends to join quickly. या ओके आता सुरू होणार. मी आता तुमच्याकडे माणूसच पाठवतो तो. Please ask everyone to join quickly. We should start with this lecture. Okay, meanwhile, let me just review what we did last time. We were talking about how to draw, we were talking about the methodology to draw velocity diagram using relative velocity method. This was the mechanism. This was the problem that we had considered. So in this mechanism, there are how many links? How many links this mechanism has? Driving link 1, this link AC 2, slider 3, BD 4, and O1D 5. There are 5 links. Fixed link should not be counted because for that link we don't have to calculate velocity because there will not be any velocity. So there are these many links. 1, you can say link number 1, but that is fixed. So let's say link number 1, for counting you can consider this fixed link, but for calculation of velocity that will not be considered. So there are how many links? 1, 2, 3, this slider 4, 5, 6. There are 6 links. Out of 6 links, 1 is fixed and remaining 5 are moving. Out of 5 links that are moving, one of the links, that is slider, is having horizontal motion along path of the slider, path of motion of the slider. And remaining all links have their direction of velocity perpendicular to link length. Direction of velocity of the links will be perpendicular to link length. For this link AC, actually we have written AC in 2 parts, AB and BC, because at B, BD is connected. So then BD, and let's say this as O1. O8 जरी लिहिला असेल तर let us consider it as O1. We have written it as O1. So this is O1, this is O2, O1D, O2A, AC, and BD. These are the links, and plus fixed link. Now, let's find out how many links are there in this velocity diagram in AutoCAD. These many links, as I said earlier, fixed link, link number 2, 3, and here we have to draw slider. So that slider should be drawn here. Let's draw the slider. We should draw slider here. Ortho on. This is the slider. This is the mechanism. I have tried to differentiate between the actual mechanism and dimension links. So these yellow color links show the mechanism. And I have also drawn velocity diagram for this. I have completed velocity diagram. Don't worry, I will repeat it for you. But then in this velocity diagram again, green colored lines show velocity diagram. This green color line shows velocity vectors and white color line shows dimensions. Okay, so let us see how I have drawn it. This should be there in front of you so that you will understand what you did. Let me start the procedure. I have already drawn velocity diagram. I'll repeat it for you. Now go to the table that is prepared for velocity diagram. These are the links O to A, AB, BC. AB and BC I have written two links because there is a one point in between on the line, that is B. AB, BC. So that is actually link AC. Then BD, DO1 and slider C. These many links are there. These are the velocity components of the links VAO2, VBA, VCB, VDB, VDO1, VCO1. It means for VCB it means it is velocity of C with respect to B. VDB it means velocity of D with respect to B, and like that. Vectors are to be written exactly in opposite way. So it is O to A and always in small letters. Velocity vectors are to be written with small letters, and letters in the space diagram are going to be capital letters. AB, BC, BD, O1D and O1C. These are the vectors. Magnitude of velocity we had calculated for driving link, and it came out equal to 50.8 millimeter per second. For all other links, velocity was not known. Direction of velocity perpendicular to link length for all other links and parallel to path of motion of the slider for slider. For piston, only for slider or piston, direction of velocity is parallel to path of motion of the slider. For rest of the links it is perpendicular to link length. We then converted it to vector length. This is in millimeter per second. Now we have to convert it into vector. So it should have length. It should be represented in terms of length. For that, scale factor taken is 1 centimeter equal to 1 millimeter per second. And since it is 50.8 millimeter per second, therefore it is equal to 50.8 centimeters. As simple as that. But we wanted to take it in millimeter because we have set unit as millimeters in AutoCAD. So this centimeter 50.8 is converted to millimeters. So it is equal to 508. And therefore, you can see this vector O to A is drawn equal to 508. So let me draw it again. Please observe it carefully so that afterwards we should not repeat the procedure for velocity diagram. Ask me any questions in between. I'm drawing this velocity diagram again. So let us draw a vector equal to 508. Why in vertically upward direction? Because direction is clockwise here. Direction of rotation of the crank O to A is clockwise, so it is upward. Therefore, this is drawn in upward direction. So we should start here from fixed points, and these two fixed points are O1, O2. We have discussed earlier that all fixed points should come at common point. So there are two fixed points here. One is O2, other is O1. All are to be represented as a common point, O1, O2 at common location. And then from O1, O2 point, draw a line perpendicular to O2A in vertically upward direction, not downward direction, because crank is rotating in clockwise direction. Okay, vertically upward direction. But now it is not perpendicular to O2A. Am I audible? Please just confirm.
Yes, sir.
Yes. So
Yes,
let
sir.
me go on. Let me finish this. And then if you have any questions, then you can ask me. So from O1, O2, draw a vector perpendicular to O2A. And that should have length, vector length equal to 508. Why 508? This is 508 mm. Okay. Then it should be perpendicular to O2A in space diagram. Now let us make that. Go to parametric, perpendicular. I made it perpendicular. Perpendicular to this line and this vector O1, O2, A should be made perpendicular. Let me name also. This is A. This point is A. Now what I should do next is AC. This link is AC and this vector is C. So they are intersecting at one point. Point C on link AC and vector C, they are intersecting with each other. So let us draw a line perpendicular to AC. From where we should draw this line perpendicular to AC? Out of A and C, which is known. Please tell me. If I have to draw a vector to represent velocity of AC, out of AC, which point is known to you?
A.
A is known to you. This is A. So from A, let us draw a line perpendicular to AC in the space diagram or configuration diagram. So let us first draw and then make it perpendicular. Let's say this is AC. I don't know where C is. Let me write here C. Please observe everything very carefully. Don't miss anything. C. I don't know location of C. I don't know magnitude of C. I just have approximately written point C here, but that is going to change later on. Then velocity of slider C. Velocity of slider C is always perpendicular to OC. And let's see its vector. Its vector is velocity of slider C. Vector is O1C. Because slider's velocity is always with respect to fixed point. Velocity of slider or piston is always with respect to fixed point. Which are the fixed points here in this diagram? Which are the fixed points?
O1 and O2.
O1 and O2.
O1 and O2.
Right, O1 and O2. Now vector is O1C. O2C लिहिला तरी तुम्ही काय हरकत नाहीये. पण O1C लिहिला आणि O2C लिहिला. Both are one and same. So I wrote it as O1C. Out of O1 and C, which is known to you? Out of O1 and C, which one is known?
O1.
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 So we should draw a vector from O1 and that is parallel to path of motion of slider. How slider is moving here? Horizontally, vertically, inclined. How it is moving?
Horizontally.
Horizontally?
Right. So this is the path of motion of the slider. This one, this horizontal line, O2C. So slider in this case is moving along horizontal path. Right. Therefore, its direction of velocity will be horizontal. its direction of velocity will be horizontal. Therefore, let us draw a line from O1 parallel to path of motion of slider, and parallel to path of motion of slider is horizontal. So let us draw horizontal line which is parallel to this path of motion of the slider. Let's draw horizontal line. I should say this as, which is the point that I will get? C. I will get C here. So I will write C here also. But
Sir,
not necessary
firstly,
to. Hello?
first you have to make that AC perpendicular, no?
AC.
Perpendicular to that link AC.
Now which one? This horizontal or this one?
That vertical one, AC one, AC.
AC. AC, how I made perpendicular?
You have to make firstly perpendicular, then intersection point.
I made it. I made it. You can see this symbol. I had drawn AC vector, then I made it perpendicular to AC in the space diagram. Can you see this symbol?
Yes,
Hello.
sir.
Yes, I
So
think
it
there's
is.
just two symbol
Hello.
over. That's why.
So is it clear now?
Yes, sir. Yes, sir.
Hello, sir.
Right. Right.
Hello,
Right.
sir.
And then O1C should be parallel to horizontal path, but it is already horizontal, so it is not necessary to make it parallel. Is that okay? Is that clear?
Yes, sir.
No need to make this O1C parallel to this horizontal line because it is already horizontal. So not necessary. Now this
Sir.
is AC, and this is O1C. They will intersect at this point and we will get point C here.
Hello, sir.
Yes.
That means we have to take parallel with slider, otherwise perpendicular.
If the link is slider, then only direction of the velocity is parallel to that motion of the slider, path of motion of the slider. For all other links, it is perpendicular to link lengths. Now in this case, slider is moving along the horizontal path, exactly horizontal path. Therefore, I have drawn horizontal line. It may happen, you may see that slider is moving along vertical path. In that case, you will have to draw line parallel to that vertical path. In some cases, you may see that slider is moving along inclined path. You have to draw a line parallel to that path. Now, right now it is parallel only. This is horizontal line, so I did not make it parallel. But let us repeat that procedure. Let's do it again. Let's make it parallel. Let's say this is parallel. I want to make it parallel to this line. Right? I made it parallel. Okay. So now what I will
Yes, sir.
get is, it was not necessary to make it parallel, but just for the sake of procedure, I did it because it was already horizontal and it was parallel. Now what you will get is, this is how you will get your point C. And then what I will do is, this is not required. Shall I delete it? Yes, no?
Yes, sir.
Yes. Shall I delete this?
Yes, sir.
Now you got point C as a result of intersection of AC drawn perpendicular to this AC and O1C drawn perpendicular to this slider path. It is nothing but O1C. Slider C is moving with respect to O1 or O2. So it is CO2 or CO1. And now what I should do? I should trim it. Shall I trim it?
Yes, sir.
Yes, sir.
Let's go to trim command. I have selected trim command. Then select this line, say enter, and then select this line. It is trimmed. Got it? Got it or
Yes,
not?
sir. Yes, sir.
Yet
Yes,
then
sir.
then I have to trim
Yes,
this
sir.
portion also. I have to trim this portion also. So select this line, say enter, select this line. It will be trimmed. Is it clear up to this stage? There are two more steps remaining to complete velocity diagram. Is it clear up to this stage? Yes, no?
Yes.
Yes.
We have drawn vector perpendicular to O to A. This is that vector O to A or O1A. Then we have drawn vector perpendicular to AC. This is that vector AC. Then we have drawn vector parallel to slider path, that is O2C or O1C. This is that O2C or O1C. Now what is remaining is this link and this link. There are two more links remaining whose velocity is to be represented with vectors. Which are the two links remaining? Please tell me. Which are the two links that are remaining?
O1D.
O1D, very good. And
BD.
BD. So which link we should do first?
O1D.
No. Okay, ठीक है, but then right now, see, we have not identified point B on link AC. There is one more point on link AC, na?
Yes, sir.
Have we located point B on AC?
No.
No.
No, sir.
We have not located point B on AC. So we have to first locate that, and then we can draw vector to represent velocity of this and vector to draw velocity of represent velocity of this link BD and O1D. How to locate any point along the link? How to locate any point along the link? That is using velocity image principle. Now what velocity image principle says? What velocity image principle says? See, ratio between AB and AC in the space diagram will be same in vector diagram. Ratio between AB and AC in the space diagram will be same as that of ratio between AB and AC in the velocity diagram. Space diagram, in the space diagram, if you have ratio of between AC and AB equal to 2, ratio between AB and AC in the velocity diagram also will be 2. So with that principle, we can identify point. With that principle, we can identify point B. Okay. We can identify point B. So how to do that? Can you tell me what are the dimensions of AB and BC in actual diagram? How much is AB? 102.
Yes, sir.
And AC is 203.
Yes, sir.
AB by AC is equal to small ab by small ac. This is velocity image principle. Ratio of AB by AC in space diagram is same as that of ratio of AB by AC in velocity diagram. Now how much is AB? 102, na? 102,
Yes,
na?
sir. Yes,
Right.
yes.
Right. And then we don't know AC, so let us dimension first. Let's dimension it first. Let's find out how much it is. Dimension allied and किती आहे रे हे सांगा बरं मला. How much it is? How much it is?
363.42.
363.42. And AB is known in the velocity diagram? Known or not known?
No, not known.
No, not known. So
No.
whatever is known, let us write down in the chat box. Capital AB is 102 mm. Capital AC is 203 mm. Small AB is known or not known? Not known. And this is 363.42. 4 2. Please solve this for AB. Hello everyone, please solve it for AB and write down your answers quickly in the chat box. Everyone should write it down. You should understand how AB is found out in the velocity diagram, because AB is the point along AC. AB is, or B is a point along the link AC. Please solve it for small AB. How much it is? अरे किती येतोय?
181.71.
Oh, so it is 184.
Yes, sir.
184.
No one.
No, 181.71.
181.71.
71.
अरे चुकतंय काहीतरी.
182 आहे सर.
182.60.
182.
हा येस.
How much it is? 182.60.
60
युनिट काय याचा? मिलीमीटर.
मिलीमीटर.
राईट. आपल्याला मिळालं का AB? ABचं डायमेन्शन कळालं का?
Yes, sir.
Now shall we draw it here? AB is equal to 182.60. AC was 363.42. Now AB will be at 182.60 from which point? A or C? B is at 182.60 millimeter from A or C?
A.
A. जरा बाकीच्यांनी सांगा बरं.
A.
AB is equal to 182.60. So point B is at 182.60
A.
from A or C?
From A.
From A. So let us draw a circle. कसा locate करायचा point? Draw a circle whose radius is equal to how much?
182.60.
182.60. And whose center is
A.
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 Point
हे
A.
सगळ्यांनी समजून घ्या. मी B पॉइंट कसा लोकेट करतोय. Since it is 182.60 from A, therefore draw a circle with A as center and whose radius is 182.60. I have drawn a circle. You got intersection point here. Now this is your point B. So this is the way you get a point B. You get a point B, right? Now from B we have to draw vector BD. Yes or no? We got point B now.
Yes.
Now we
Yes,
have to
sir.
draw a vector BD. And for vector BD, B and D, which one is known?
B, sir.
B.
Right, this is vector BD. Vector BD is to be drawn to represent velocity of link BD. Velocity of link BD is VDB. Out of B and D, which is known? B or D?
B.
B.
B,
B.
sir.
B.
B, yes. So from B, let us draw a vector. From B, let's draw a vector. But it should be perpendicular, parallel. काय करायला पाहिजे?
Perpendicular to the BD.
Perpendicular to BD. So I am doing same thing. Let us draw vector BD for which B is known but D is not known, and its magnitude is not known, but its direction is perpendicular to this BD, this link BD. So let us draw a line, then make it perpendicular. Let us draw a line approximately perpendicular and then make it perpendicular perfectly. I have drawn it. मी हे D नाव लिहून घेतो आणि नंतर आपण ते फायनल करूया. कुठं त्याचं लोकेशन येईल आपण नंतर बघू. So this is D. Okay, I have drawn BD. इथं मी B नाव देतो म्हणजे तुम्हाला कळेल. याच्यात तुमची शंका काही राहणार नाहीये if you observe it carefully. I have identified point B. So let me name that point B here. B, and this is BD. Now let us make BD perpendicular to capital BD in the space diagram. कुठं जायचं? Parametric, perpendicular. I want to make this perpendicular. Sorry. Parametric, perpendicular. This is first object, and this is the object which is to be made. अरे काहीतरी प्रॉब्लेम आहे, काहीतरी प्रॉब्लेम. हा प्रॉब्लेम येतोय. ठीक आहे, आपण काय करूया त्याला. लेट अस ड्रॉ लाईन इन दिस डायरेक्शन आणि नंतर आपण एक्सटेंड करून घेऊ. इकडे केल्यावर येईल. आता बघूया. पॅरामेट्रिक, परपेंडिक्युलर. Is it done?
Yes, sir.
This line is perpendicular to it is perpendicular to this line. आता आपण तिकडे एक्सटेंड करून घेऊया. एक सर्कल इथून ड्रॉ करू. B as center. ओके, विथ B as center. अरे इथला B कुठे गेला आपला? Annotate, multi-line text. And then go to extend. इथं trim आणि इथं खाली extend आहे. So select this object first and then select. No. Select this object first and then select this object. So it is extended. आता extend केल्यानंतर इकडचा भाग trim करून टाकूया. Trim. Trim केला मी. So this is BD. Now BD is drawn. Last vector is, शेवटचा वेक्टर कुठला राहिलाय सांगा. लास्ट वेक्टर कुठला राहिलाय? O1D. O1D, I should draw vector O1D perpendicular to O1D in the space diagram. And vector name is, let's look to this diagram. Let's look into this diagram. O1D, vectors are small o1 and small d. Out of O1D, which is known to you? O1. O1 is known to you. Vector, sorry, from this point O1, draw a line perpendicular to O1D in the space diagram. So let us draw it approximately perpendicular. I have to draw vector that represents, I have to draw finally a vector that represents velocity of link O1D in the space diagram. So vector is small o1, small d. Out of that, small o1 is known to you. So we have to start from O. Whatever is known, from that point you should start. So from where to start, you will get answer. Out of 2 points, whichever is known to you, whichever is available, from there you can start. Now this vector O1D, which is to be started from small o1, should be drawn perpendicular to O1, should be drawn perpendicular to O1D. Now let us draw it approximately perpendicular to O1D. Okay. And now let us make it perpendicular. Go to parametric. Select this line. No, इथं परत काहीतरी प्रॉब्लेम येतोय. तर आपण ती लाईन या बाजूला करून घेऊया. There is some problem. So let us draw it approximately perpendicular here. Let us make it perfectly perpendicular. Perpendicular कोणाला हा झाला का perpendicular? Yes or no?
Yes, sir.
आता परत तीच प्रोसिजर करूया. Let us draw a circle with O1 as center and then go to extend command. Select this circle up to which
Hello, sir.
it is. Hello.
Hello, sir.
हॅलो सर ती
हा,
लाईन
yes.
डायरेक्ट मूव्ह केली तर चालणार नाही का वरती
Yes, sir.
हा चालेल, काय
म्हणून
हरकत नाही.
select
तुम्ही कुठल्या
करून.
you do it in your own way, no problem. I feel I can do it quickly with extend command with precision, so I did it. Extend command. Extend.
हॅलो सर.
Yes.
सर आधी सर्कल सिलेक्ट करून मग नंतर एक्सटेंड कमांड सिलेक्ट करा.
नाही केलं ना, झालं की हे बघ.
हा
Extend.
सर.
Yes, extended. Now let us remove the circle. This way you will be able to practice different modify commands, because there is lot of use of modify commands in drawing not only velocity and acceleration diagrams but any kind of diagram. So now let us go to trim command. Trim, then select this line, enter, and this line, then select this line, enter, and this line, then select this line जितना आपल्याला ट्रिम करायचे, जी लाईन ट्रिम करायची, then select this. हे सर्कल पण काढून टाकूया. And now let me give a color to line so that you will understand which is actually velocity diagram. इथं पहिल्यांदा आपण नाव देऊ. What I should name here? D na?
डी डी
D, sir.
Yeah, right. Oh, O1 A, AC, AB, BD, DO1 or DO2. आता आपण याचे कलर चेंज करू म्हणजे तुम्हाला पटकन कळेल. Am I audible now?
Yes, sir.
येस सर
Right.
Yes, sir.
So, okay. So let's change the color. Let's take this color. येलोच घेऊया म्हणजे पटकन दिसतोय. Yes. Whatever I have shown
Excuse me,
with yellow color, whatever is shown with yellow color is a velocity diagram. Rest all are, I think this one, this is dimension. So let me give remaining dimensions also.
excuse me, sir.
Yes.
तर ते वेलॉसिटी डायग्राम मध्ये ते स्क्वेअर्स कसले आहेत sir?
कुठले स्क्वेअर आहेत?
ते असे ट्रान्सल्युसंट स्क्वेअर आहेत ते काय त्याला काय म्हणजे ते घालू शकत नाही का आपण?
कुठे आहेत ते स्क्वेअर कुठे आहेत?
तर ते
डायमेन्शन
स्क्वेअर
अरे हे का?
साइन येते परपेंडिक्युलरची.
नाही सर. हा
हा.
ते मध्ये मध्ये वेलॉसिटी डायग्रामच्या मध्ये.
हे
हा ते काय
परपेंडिक्युलरची
चार.
साइन सर ती.
अरे ते
Parallel आणि
साइन आहे
perpendicular ची sign.
परपेंडिक्युलरचा.
ओके मग ते घालवू शकत नाही आपण ते म्हणजे.
घालवता येईल आपल्याला. ड्रॉइंग मध्ये बघूया आपण दिसते का. ड्रॉइंग मध्ये दिसत असेल आपल्याला नको असेल तर कसं घालवायचं बघू आपण. पण ते सिम्बॉल आहेत त्यांनी काही फरक पडत नाहीये.
ठीक आहे.
पॅरलल, परपेंडिक्युलर, कॉन्सेंट्रिक, टँजेंट हे सगळे सिम्बॉल्स दाखवतोय. राईट?
Yes.
नाउ लेट अस गिव्ह रिमेनिंग डायमेन्शन्स ऑल्सो. सॉरी, अलाइंड. आपल्याला हे सगळे डायमेन्शन पाहिजेत. हे आहे 304.07. हे आहे 325.07. This is 393.84. ओके. आणि हे तर झालंय आपलं. आपल्याला हे एक जर पाहिजे असेल this is 182.6. Okay. I have drawn this velocity diagram with every details. फक्त याच्यात आपले ॲरो दाखवायचे आहेत. ॲरोची डायरेक्शन मी तुम्हाला सांगेन. सगळे डायमेन्शन पण आहेत. आता प्लीज कॅप्चर इमेज ऑफ दिस डायग्राम. मला तुम्हाला डायमेन्शन सांगायचे आहेत. प्लीज कॅप्चर इमेज. प्लीज टेक अ फोटोग्राफ एव्हरीवन.
हॅलो सर,
घेतला?
बीडीची डायमेन्शन राहिले सर.
बीडी का? बीडी घेतली ना रे. हे काय 393.84.
ठीक आहे सर.
ओके, गॉट इट?
येस सर.
राईट. सो घेतला का फोटोग्राफ याचा? हॅव यू कॅप्चर्ड इमेज?
Yes, sir.
Right. Now let us go to that table. Let's go to table. First write down scaled length. Vector length जी आपल्याला डायग्राम मधनं दिसते ती लिहून टाकूया. AB ची किती आहे रे? AB is equal to, अरे आपल्याला डायग्राम मध्ये जी वेक्टर लेंथ दिसते ती लिहूया ना इथं. टेबल मध्ये लिहू शकतो की नाही?
येस सर.
Scale length of the vector. How much is AB? Small ab?
182.
सांगा. 182.60.
182.6.
BC सांगा. BC, how much is BC in the diagram? हे कुठनं लिहितोय आपण? डायग्राम मधनं लिहितोय. आणि डायग्राम मध्ये ज्या वेक्टर लेंथ आहेत त्या मिलीमीटर मध्ये आहेत, सेंटीमीटर मध्ये नव्हे. Therefore we are writing it under millimeter column. Our unit was millimeter. So whatever vector lengths we got, those are in millimeters. BC किती आहे? How much is BC? 363.42. BD सांगा. How much is BD? How much is BD?
393.84.
393.84. Correct करेक्ट सांगा, चुकवू नका. 393.84. OD1. OD1 म्हणजे कुठला येणार आहे आता? O1D किंवा O2D. O1D किंवा O2D किती येतो?
325.07.
25.07. आणि फायनली राहिला स्लायडर. स्लायडरचा वेक्टर काय असतो? स्लायडर इथं आहे, त्याची वेलॉसिटी नेहमी फिक्स पॉइंटच्या विथ रिस्पेक्ट टू असते. सो इट इज C and fixed point. Velocity of slider is always with respect to fixed point. So it is CO1 or CO2. I have already written it here. Vector that represents velocity of slider C is O1C. So how much is O1C?
304.07.
304.07. आता हेच मला सेंटीमीटर मध्ये सांगा. सेंटीमीटर मध्ये काय होणार? डिवायडेड बाय 10 ना?
हॅलो सर.
18.26.
येस सर, तुम्ही बीसीच्या जागी एसीची डायमेन्शन घेतली आहे.
तुम्ही मला करेक्ट सांगा ना रे.
हो सर.
BC सांगा बरं.
180.82
डायमेन्शन तुम्ही लिहिलेलं नाही.
हा सर, 180.82 येते.
एक मिनिट, हे बघा
हो
BC
सर, मायनस करायची तिथे.
करेक्ट मायनस करायची, इथं दिसत नाहीये. राईट, पण दाखवूया आपण, काय हरकत नाहीये. आपण दाखवूया ना, करेक्ट करू. BC 180.82, राईट?
येस सर. येस सर.
Yes, sir.
BC 180.82. बाकी सगळं करेक्ट आहे का रे?
Yes, sir.
राईट.
हो
आता
सर. हो सर.
लेट अस जस्ट राईट इट इन टर्म्स ऑफ सेंटीमीटर. सेंटीमीटर म्हणजे डिवायडेड बाय 10.
18.26.
18.26 सेंटीमीटर. मिलीमीटर मध्ये आहे, त्याला डिवायडेड बाय 10. 18.08. 39.38 मिलीमीटर मध्ये आहे, त्याला डिवायडेड बाय 10. 32.50
32.50.
and 30.40. इज इट ओके? आपल्याला सगळ्या वेलॉसिटी मिळणार आहेत इथंच. बघा किती सिंपल पद्धत आहे. हा टेबल फॉलो केला तर यू विल बी ॲट इज. नाव लेट अस फाइंड आउट वेलॉसिटी. आपलं युनिट काय सांगतं? 1 सेंटीमीटर इज इक्वल टू 1 सेंटीमीटर इज इक्वल टू 1 मिलीमीटर पर सेकंड. मग आपले 18.26 सेंटीमीटर आहेत, म्हणजे किती मिलीमीटर पर सेकंड?
18.26.
व्हेरी गुड. कारण ते कशावर ठरतं? तुम्ही स्केल फॅक्टर वरती काय लिहिलाय. सो यू शुड राईट करेक्ट स्केल फॅक्टर हिअर. आता 1 सेंटीमीटर इक्वल टू 2 मिलीमीटर पर सेकंद असता तर हे किती आलं असतं? 9.13 आलं असतं ना?
हा, डिवायडेड बाय 2.
1 सेंटीमीटर इक्वल टू 2 मिलीमीटर पर सेकंद अशी जर आपण स्केल फॅक्टर घेतली असती तर सेंटीमीटर आलेत 18.26, पण 1 सेंटीमीटर म्हणजे 2 मिलीमीटर पर सेकंद आहे. राईट. 36 आला असतं. सॉरी 36.52 इतकं आलं असतं, बरोबर ना?
डबल झालं.
1 सेंटीमीटरचे 2 मिलीमीटर. ठीक आहे, तसं एखादा एक्झाम्पल आपण पुढच्याला घेऊया ऍक्सेलरेशनच्या वेळेला, म्हणजे तुम्हाला लक्षात येईल. सो लेट अस डू नॉट confuse over there. We will have such example where we will have scale factor other than 1:1, and then we'll see what will be final values. This is 18.08. Why it is same? Because scale factor is 1 centimeter equal to 1 millimeter per second, 39.38 millimeter per second, 32.50 millimeter per second, and 30.40 millimeter per second. Done. Our velocity diagram and unknown velocity components we have got answers for velocities, unknown velocities of the links. Which links? AB, BC, rather it is AC only one link AC, BD, DO1 and slider C. So what are your answers? Answers are: velocity of link AB is 18.26 millimeter per second. Velocity of link BC is 18.08 millimeter per second. Velocity of link BD is 39.38 millimeter per second. DO1 is 32.50 millimeter per second, and velocity of slider is 30.40 millimeter per second. If required, you can write it in meter per second. It is just matter of conversion. If you have to write it in centimeter per second or meter per second, you just need to convert. That will be just matter of conversion. If you have to write it in meter per second, you have to divide this value by 1000.
Divide.
Yes.
Divides.
Yes, divide. 50.8 millimeter per second आहे ते. मीटर पर सेकंड मध्ये लिहायला काय करायला लागेल? डिवाइड करायचं का मल्टिप्लाय करायचं?
Yes sir, divide, yes sir.
Yes. 1 meter is equal to 1000 millimeter and it is
Yes, sir.
50.8 millimeter per second. So you have to divide it by 1000. If you have to write it in centimeter,
Divide by 100.
divided by 100 का 10 रे?
10, sorry.
10. 1 centimeter is equal to 10 mm. So divided by 10, you will get it in centimeter per second. So you got the answers. It is done. We are going to start with acceleration diagram. Let me know if you have any questions here. Please discuss in the chat box. Whatever you have understood, whatever you have not understood, please discuss for next 2-3 minutes so that meanwhile we will have attendance. Will you discuss?
Sir.
Yes, no?
Hello, sir.
Chat box मध्ये तुम्ही please write down whatever you have understood or not understood in the chat box. If there are any questions, I will look to your questions in the chat box and then I will answer. Is that okay? Yes, no?
Hello, sir.
Yes, please write down. Everyone should participate in the chat box discussion. So let us have attendance. Meanwhile, please write down chat box. I should see n number of comments in the chat box. I should see n number of comments in the chat box. Meanwhile, let us have your attendance. जरा पवार ना बोलवा बरं. मी आता ते काम तुमची वाट बघून एक मिनिट लेक्चर चालू. नाही
Excuse me sir.
येस.
सर ते स्केल फॅक्टरचं जरा सांगा ना सर.
एक मिनिट, तुम्ही स्केल फॅक्टरचे क्वेश्चन तुमच्या चॅट बॉक्स मध्ये लिहा.
आहे सर, आहे.
बघूया बाकीचे कोणाला काय सांगता येते का. लेट अस डिस्कस इन द ग्रुप. I want discussion in the chat box. You should write whatever you have understood, whatever you have not understood. Scale factor is one where if you want to, if your dimension is less and you want to increase, मग आपण काय करतो, scale up करतो. And if your dimension is large and you want to decrease, then you have to scale down. मग आपण स्केल फॅक्टर ठरवतो, वेदर इट इज 1:2, 1:4, 1:10. 1:2 म्हणजे आपण कमी केलेलं असतं आणि जर आपण वाढवलेलं असेल तर 2:1, 2:4, सॉरी 2:1, 4:1, 10:1, 20:1. आपण स्केल अप करतोय. ऍक्च्युअल ड्रॉइंगची साईज आपण वाढवतोय का कमी करतोय. याच्यानुसार आपण आपला स्केल फॅक्टर लिहायचा आहे. आज आपण जो स्केल फॅक्टर घेतला होता तो 1:1 होता. पुढच्या वेळेला आपण ऍक्सेलरेशन डायग्रामला आपण स्केल अप करणारा किंवा स्केल डाऊन करणारा स्केल फॅक्टर घेऊया. इज दॅट ओके?
ओके. मग सर ते 1 सेंटीमीटर इज इक्वल टू ते 1 मिलीमीटर स्क्वेअर ते आहे का स्केल फॅक्टर?
हा राईट, दॅट इज स्केल फॅक्टर. आपण काय केलंय, 1 सेंटीमीटर म्हणजे 1 मिलीमीटर पर सेकंड, कारण आपली वेलॉसिटी मिलीमीटर पर सेकंड मध्ये होती. आता ती आपल्याला लेनच्या डायमेन्शनच्या स्वरूपामध्ये प्रेझेंट करायची आहे. आपलं वेक्टर लेन मध्ये डायमेन्शन काय आहे सांगा बरं? लेंथ आहे. वेक्टर डायग्रामला डायमेन्शन काय आहे, युनिट काय आहे? लेंथ युनिट आहे. लेंथ युनिट आहे. लेंथ युनिट. वेक्टर डायग्राम मध्ये युनिट आहे लेंथ. इट कॅन बी आयदर मिलीमीटर, सेंटीमीटर, मीटर, किलोमीटर. बट इन AutoCAD which unit we had set?
mm per second.
Array, millimeter. We set it as millimeter. Right?
Yes, sir.
So therefore we have to convert our actual dimension of velocity in millimeter per second to length unit, either centimeter or millimeter. पण आपण मिलीमीटर मध्ये काम करतोय, त्यामुळे या दोघांमधलं आपण रिलेशन लावलं. 1 सेंटीमीटर in length unit is equal to 1 millimeter per second in velocity unit. Let me repeat. 1 centimeter in length unit is equal to 1 millimeter per second in velocity unit. Unit of velocity and unit of vector length या दोघांमध्ये आपण एक रिलेशन लिहिलं. That is called a scale factor. We will have a different scale factor than 1:1 next time, and then we will solve problem based on acceleration diagram. Is that okay?
येस सर. पण ते सर म्हणजे ते स्केल घेणं गरजेचं असतं, म्हणजे जर आपण तसंच घेतलं तर म्हणजे
ते सांगतोय तो तुम्हाला समोरचे डायमेन्शन बघून लक्षात येईल स्केल फॅक्टर घ्यायचा आहे की नाही.
अच्छा.
स्केल फॅक्टर घेणं हे आपण ठरवायचं असतं. आपल्याला स्केल अप करायचं आहे का स्केल डाऊन करायचं आहे ते आपण ठरवायचं रे. याच्या आधी कधी स्केल फॅक्टर घेतलाच नाही का? स्केल फॅक्टर घ्यायचा म्हणजे तुमच्या घराचं एखादं ड्रॉइंग इंजिनियर ज्यावेळेला तुम्हाला ड्रॉ करून देतो त्याला काही स्केल फॅक्टर लावलेला असतो असं वाटतं का तुम्हाला?
मी नाही बघितलं सर कधी. मला
लावलेलं असतं, कारण तुमच्या घराचे डायमेन्शन असतात 50 फूट, 40 फूट. मग 50 फूट पेपरवरती ड्रॉ करता येतं का हो?
नाही सर.
राईट, दॅट इज स्केल फॅक्टर. ऍक्च्युअल 50 फीट आहे, बट यू कॅनॉट ड्रॉ इट ऑन पेपर. ऍटलीस्ट मॅन्युअली करताना 50 फीट यू कॅनॉट ड्रॉ. एवढं पेपरवरती बसेल का? नाही. मग आपण काय करतो?
स्केल डाऊन.
स्केल डाऊन करतो. तसं स्केल अप पण करण्याची गरज पडते. मग आपण काय करतो? 1 सेंटीमीटर इज इक्वल टू 1 फीट. राईट? जस्ट एज अन एक्झाम्पल, 1 सेंटीमीटर इज इक्वल टू 1 फीट. सो 50 फीट म्हणजे किती सेंटीमीटर?
50 सेंटीमीटर.
50 सेंटीमीटर. मग ते 50 सेंटीमीटर ड्रॉ करा. तेवढे बसतात का बघा. नसेल तर अजून स्केल डाऊन करा. समजलं का स्केल फॅक्टर काय असतं?
Yes, sir.
Yes, sir.
Okay. So let us have your attendance now. This was the last online lecture of the semester. From Monday onwards, we will go ahead with offline lectures.
सर मग ते टाइम टेबल सर ऑफलाईनचं वेगळं असणार आहे का असंच असणार आहे?
नाही, वेगळं टाइम टेबल आहे ना. आता तुमचे प्रॅक्टिकल पण सुरू होणार. प्लीज कॉन्टॅक्ट युअर मॉनिटर, क्लास मॉनिटर, so that you will get timetable. Okay?
Yes, sir.
And be ready. Quickly respond to your attendance. Be ready. You should be fast. Right. Let me know who all are present or absent. 180, 1005. 180, 1014. Please mute. Who has unmuted? Please mute. Mute yourself. 14 is present.
Present, sir.
Okay, 29,
Present.
50,
Present, sir.
9001, 9002, 9004, 9005,
Present, sir.
9000, 9006.
Present, sir.
8.
Present, sir.
अरे 4 आत्ता कसं मध्ये सांग ना. That's why I said be ready for your attendance. You should quickly respond. 8,
Present, sir.
9,
Present, sir.
10,
Present, sir.
11, absent, 12,
Present.
13,
Present, sir.
14,
Present, sir.
16,
Present, sir.
17,
Present, sir.
18,
Present, sir.
19,
Present, sir.
20,
Present, sir.
22.
Present, sir.
आपण रेग्युलर स्टुडंट बघतोय आता, अजून डायरेक्ट सेकंड इयर सुद्धा झालेलं नाहीये. 24,
Present, sir.
25, 26,
Present, sir.
27,
Present, sir.
28, 29, 30, 31,
Present, sir.
Present, sir.
30, 31 both,
Yes, sir. Yes, sir. Present.
33,
Yes, sir. Present, sir.
34, 34, 35, 36,
Present, sir.
37, 38,
Present, sir.
30, 40,
Present, sir.
43,
Present, sir.
45, 47, 48, 51, direct second year 9001, 9002, 9003,
Present, sir.
direct second year 4, 5,
Present, sir.
6.
4, sir. Present.
Yes? Okay, 6, 7, 8,
Present, sir.
9, 10,
Present, sir.
11, 12,
Present, sir.
13,
Present, sir.
okay. Then 14,
Yes, sir.
14 present,
Yes, sir.
15, 15, 16, 17, 18, 19.
सर 18 प्रेझेंट आहे.
म्हणायचं कधी?
सर तुमचा आवाज
Present म्हण.
पण इकडे.
Okay, 20. Please respond so that I can mark your attendance. 21, 22, 23,
Present, sir.
24,
प्रेझेंट सर.
Present, sir.
26.
Sir, 25 present.
Okay, 26, 27,
Present, sir.
28, 29, 30,
Present, sir.
31,
Present, sir.
32,
present.
32, 33,
Present, sir.
34, 35,
Present, sir.
Sir. Sir, 28.
36, 36, चालेल. 37,
Present, sir.
38, 39, 40.
40 present, sir.
Okay, ठीक आहे. You may leave now.
Sir, 28 present.
ग्रुप वरती टाक तुझा नंबर.